In this problem, we're given the energy absorbed by the box in the graph below. We're asked to calculate and sketch the current flowing into the box. Also calculate the charge which enters the box between 0 and 12 seconds. So we have energy, and if we remember, power is equal to the time rate of change of energy. So the power waveform is going to be controlled by the slope of the energy waveform. So if we look, for instance, from 0 to 2 seconds, we see that the slope is 2.5. So then P of t has a value of 2.5 watts between 0 and 2 seconds. Now between 2 and 4 we can see the slope is 0. From 4 to 6 the slope is negative, and in fact it has a value of minus 2.5. 6 to 7 is 0. From 7 to 8 it has a value of minus 2.5. We go minus 2.5 in 1 second. So it's minus 2.5 between 7 and 8 seconds. From 8 to 10 it's 0. And in the last interval from 0 to 10, it changes 2.5 over 2 seconds. And this is a positive slope, so it's going to be 1.25 watts between 10 and 12 seconds. So now we're ready to sketch the power waveform. So we have P of t in watts. Between 0 and 2 it has a value of 2.5. Between 2 and 4 it has a value of 0. Between 4 and 6 it has a value of minus 2.5. From 6 to 7 it has a value of 0. From 7 to 8 it has a value of minus 2.5. From 8 to 10 it has a value of 0. And then from 10 to 12 it has a value of 1.25. So that's the energy waveform. Now we can calculate the current, because if we look at our diagram we can see that we know that power is equal to V times I. So when we know that I is a power waveform divided by 10, so P of t is V times I. So I then is P over V, and that's going to be P of t divided by 10. So our current waveform looks exactly like our power waveform, except it's scaled. So for instance, from 0 to 2 we have a value of 0.25. From 2 to 4 it's 0. From 4 to 6 it's minus 0.25. From 6 to 7 is 0. From 7 to 8 again minus 0.25. 8 to 10 is 0. And then from 10 to 12 it has a value of 0.125. So there's our current waveform. Now we know that Q is the integral of I dt. So now it's a matter of taking the area under that curve. So if we look, we'll have Q then. The area under here is 0.25 times 2. That's this area. This next area is minus 0.25 times 2. The next area, which is this one, we have minus 0.25 times 1. And in this last area, we have plus 0.125 times 2. And I believe if you'll look, this turns out to be 0.